Hi everyone, welcome to this introductory video on pseudocode and its connection to Python programming. Whether you are just getting started in AI or exploring the foundations of computational thinking, this session will help you understand how to plan your algorithms and turn them into working Python code. Let's begin with the basic question. What is pseudocode? Pseudocode is a way of describing an algorithm using plain, structured English without worrying about the rules of a specific programming language. Think of pseudocode as the blueprint or recipe that helps you organize your logic before you write real code. Well, why not just write code directly? This is because pseudocode helps you focus on the logic and not on the syntax. Pseudocode is easier to read and to write than programming code. It encourages clear thinking, which is especially helpful in solving problems, communicating ideas, and debugging. Programmers frequently utilize pseudocode as a transitional step in the programming process between the initial thinking phase and the writing of actual code that can be executed. Here are some common pseudocode keywords and what they mean. You can see this as a cheat sheet for basic pseudocode elements. These keywords easily translate into Python structures. Although using standard pseudocode structures that other programmers can understand is typical professional courtesy, there is no predefined grammar you must adhere to when writing pseudocode. The most crucial element is that pseudocode helps you organize your ideas and execute your plan when coding a project alone. Well, let's apply this to a problem. In this problem, what we see in the slide, we want to find the maximum of three numbers. So we ask the user three numbers and we display the largest one. Well, here is the pseudocode for this problem. In line 1 to 4, we ask the user for three numbers. Then in line 6, we assume that the first number is the maximum. In lines 8 to 10, we compare the second number with the first number that we assume to be the maximum. So if number 2 is greater than number 1, we set number 2 as the new maximum. We do the same for number 3 in the lines 12 to 14. If number 3 is greater than the maximum, then the new maximum will be number 3. In line 16, we display the maximum number. Well, and here is the equivalent of the pseudocode in Python. In other words, we translated the pseudocode into Python language. Here is another example. In this problem, we ask the user to enter the temperature in Celsius, and then we show the equivalent value in Fahrenheit. So here is the pseudocode. In line 1, we ask the user to enter the temperature in Celsius. Then in line 2, we convert the temperature from Celsius to Fahrenheit. And finally, in line 4, we display the result. And here is the Python version. It is good to pause the video and take a close look at the conversion from pseudocode to Python programming language. Let's walk through a final example together. In this problem, we ask the user to enter a word. Then we check to see if the word is a palindrome. Remember that a palindrome is a word that reads forward and backwards the same, such as the words madam or rotator. Well, here is the pseudocode for this problem. In line 2, we ask the user to input a word. And in line 3, we make a variable named reverse word, which is initially empty. Then in line 5 and 6, we reverse the input word by the user. We use a for loop for this. In line 9, we check whether the input word is the same as the reverse word. Then, if the input word is the same as the reverse word, we display the text, "This is a palindrome." Else, we display, "This is not a palindrome." And here is the Python version. I recommend you to pause the video and take a close look at the conversion from pseudocode to the Python programming language. Here is what we covered in this video. We covered what pseudocode is and why it matters. We discussed how to turn pseudocode into Python, and we also saw some examples that show how logic turns into code. Well, thanks for watching, and be sure to try out the examples yourself and practice writing your own pseudocode before jumping into code. Until next time, and keep thinking like a computer scientist.